So, hello students, welcome back to the online lecture series for RCC. The topic for today's online lecture will be working stress method, which is also known as WSM. In WSM, the term modular ratio is used as we have discussed in the earlier lectures. The term modular ratio, which was denoted by small m, it will be used. And this method is also known as elastic method because Hooke's law is valid in this. As you know that Hooke's law is stress is directly proportional to strain within elastic limit. Okay, so as below you can see here, I have drawn stress and strain graph and curve for concrete in WSM and for concrete in LSM. It is just for comparison. In WSM, the stress and strain are linear. Okay, it is directly proportional here. As the values of stress increases, the strain value also increases. But in LSM, it is proportional up to a certain limit and then it becomes. So in LSM, the stress strain curve is different as compared to WSM. Okay, and also we have already discussed that it is also known as modular ratio method because it can't be solved without knowing the value of modular ratio, that is small m. Also the factor of safety used here is 3 for beams and 4 for columns or direct compression. Okay, in this method the section becomes heavier and uneconomical because load considerations are much as compared to LSM. So the section becomes heavier and much material is used, so it becomes uneconomical, means the cost is high. Working loads are considered here. Okay, liquid retaining structures like water tank are designed with WSM because cracks are not allowable in these structures. Okay, so as mentioned that no cracks are allowed here because the construction of RC structure is done to a higher limit in WSM. So the important structures like water tank is designed by WSM because it does not allow any cracks in these structures. Okay, so in this method there are certain assumptions which is also mentioned in your IS code 456/2000 in page number 81. You can see there. Okay, so the assumption number 1 for the WSM is the section remains plane before and after bending. Okay, so as you can see from this figure, when we cut this section into smaller section, the stress and strain is constant. Okay, and the section remains plane before and after bending. Okay, so this is strain trigram. This ET is for steel and EC is strain for concrete, so it is linear here. Okay, second assumption is that all the tensile force or tension is taken by steel only, means concrete will also bear some tensile load, but the total tension load is considered to be taken by steel and total compression load is by concrete. Okay, so there is a section here mentioned which is having a width of small b, total depth of capital D as we have already discussed, and here is small d. Small d is effective depth. What is the basic difference between capital D and small d? Capital D is the overall depth which is from the top fiber to the bottom fiber. Okay, but effective depth is the distance or depth from top fiber and to the CG or center of the steel placed in the tensile zone. Okay, so capital D comes out to be small d plus cover. So what is cover, or it is also known as clear cover? Cover is provided to protect the steel from the outer environment or from wear and tear if happens from outside. So we provide a cover. Here cover is provided by this formula. Cover is equal to nominal cover. Nominal cover is as per the IS code. I will mention it afterwards. Plus phi of steel used in stirrups and phi by 2 of main steel. Okay, so I will draw a section here to explain you that if this is a section of RCC and steel is placed here. Okay, so and steel is placed at the top also. for support. So you must have seen that there is a covering of steel provide the main steel. This is known as stirrups. So the cover will be nominal cover, which is this distance, plus 5 of stirrup. Stirrup is taken full, and 5 by 2 of the main steel, which is here. Why we have taken 5 by 2? Because the effective depth is the distance from top fiber to the CG or center of the main steel. Okay, so there are important highlights here. If main reinforcement is provided in tension zone only, then it is known as a singly reinforced section. Means if the main steel is the steel which is taking the tensile loads, if it is provided in the bottom zone or on the tension zone only, the section will be known as the singly reinforced beam or section. And if the main steel is provided in the top zone, that is compression zone also, then it will be known as a doubly reinforced beam. The major difference we will discuss in the next lectures. Also, the main reinforcement is to be taken care for bending moment and tension. Okay, so the main reinforcement is responsible for taking the bending moment. Okay, so according to IS code, there are values for minimum clear cover, like in beams the minimum clear cover, or you can say it as nominal cover, is to be provided as 25 mm. For slabs it is 20 mm, column it is 40 mm, and footing is 50 mm. Okay, so the total depth, as I've also mentioned earlier in the formula, that total depth is d plus d dash. Okay, where capital D is equal to small d, that is effective depth, plus clear cover plus 5 by 2. 5 by 2 is the main steel, and if we are providing stirrup, the diameter of stirrup will also be added here. Okay, so the total tension is taken at the CG or center of gravity of the steel. Okay, so there is a small example here. If an RCC beam of 200 into 300 mm is reinforced with 3 bars of 20 mm phi, this notation means there are steel provided, 3 bars of steel provided, each bar is having 20 mm diameter at clear cover of 30 mm. Okay, so there is given the clear cover, means clear cover is provided to you. What will be the effective depth of beam? So by using the formula, we will put the values here. Clear cover plus 5 by 2, so clear cover is 30 and the steel diameter is given here 20 mm. So 20 by 2, so the d dash becomes 40 mm, and effective depth becomes d minus d dash, that is 300 minus 40, it becomes 260 mm. So the correct answer is B for that. Okay, also third assumption will be there will be a perfect bond between steel and concrete, means we assume that the bond between steel and concrete is perfect, so therefore strain in concrete will be equal to strain in steel, means the strain which will be coming on concrete will be equal to strain coming on steel, because both are perfectly joined or bonded in the RCC. The fourth assumption is the section should be homogeneous, as we have already discussed in WSM, that the section should be homogeneous for analysis, that is use equivalent cross sectional area for analysis. So before analyzing the section, we have to convert the section into equivalent or homogeneous section. Okay, fifth point is a modulus of elasticity of steel and concrete will remain constant throughout. Okay, so the modulus of elasticity, that is ES for steel and EC for concrete, should remain constant throughout, means there is no changes allowed. And sixth is Hooke's law will be valid, that is stress diagram will be linear, means if we are drawing stress diagram for steel and concrete, it should be linear. Okay, so that's all for today. Till then, take care. Bye bye.